In this video, we're going to be looking at transformations, but enlargements this time. Now, mathematical enlargements, they require two different things for us to be able to work with them. You need to have a scale factor of enlargement, how many times bigger the object is going to become, or indeed smaller. And we also need to have what's called a centre of enlargement, which is the point from which the enlargement will take place. Now, the easiest way to do a mathematical enlargement is actually using square paper, and it's actually done by counting squares. And you have to be able to count how many squares horizontally along you've gone and how many squares vertically up you've gone. And then you've got to do a bit of simple multiplication. So the easiest way to do this is to look at an example. So then here we've got a T-shape. We're going to enlarge this T-shape. Scale factor 2, so it's going to be twice the size. And the centre of enlargement is going to be the origin, 0, 0. Now the process is this. All you do is you first of all mark the centre. And from the centre you've got to pick one point on the new shape, and you've got to count how many squares along and how many squares up do you go to get to that point. So we've gone 3 up and 2 along, and we can write that in our vector form that we've talked about previously, and that's going to be 2, 3 in a column vector. Now, because we're doing a scale factor of 2, we're going to double those values from our vector. So we're going to times it by 2. So we had 2, 3. We're going to do 2 times that, and that's going to become 4, 6. Now, all we're going to do is we're going to count from the centre of enlargement exactly those values from that new vector that we've got there. So we're going to go 4 across, and then we're going to go 6 up, and we're going to mark a new point. And that is the point that the original one that we identified has moved to. Now we can be really clever because we know the shape is going to be double the size. And just by looking at the original shape, we can fill in the missing blanks because we know each length is 2 times bigger than it was before. Now, you don't have to. You could do it by counting for each case, but you'll find this much easier. You get one of the points, and then you think about doubling everything because of scale factor 2. Let's look at another example. Another T-shape. The T-shape is in a different position here. We're going to have a different centre of enlargement and a different scale factor. So, scale factor 3, the centre of enlargement is 4, 4. So our starting point, as before, is to identify the centre of enlargement. We put them across there. And then we select a point that we're going to enlarge. So I'm going to take this point here. How do I get to there? Well, I go 2 back and I go 1 down. Now, because I'm going back and down, I've got negative values for my vector there. So my column vector is going to be -2, -1. Now we said a scale factor 3 enlargement, so we're going to multiply those values in that vector by 3. And that's going to give us -6, -3. So going back to our centre of enlargement, counting -6, so 6 backwards, and then 3 down. And there, that point has moved to. Now, we're going to build the rest of the shape from there. This time, everything's 3 times bigger. So we know that the length down the side of the T there, it was 1, now it's 3, and so on. So each length is 3 times what it was in the original. So just by careful counting and multiplying each length by 3, we can now fill in where our T is going to go to. And so we've enlarged with a scale factor of 3. what's nice about mathematical enlargements is we can check them. The first thing we've got to do is look at our image and say, is it scale factor times bigger than the original one? So in my T shape here, I can see that every side is 3 times the size of the original one. So that's good. So I'm halfway there. Then the nice thing we can do is if we can draw what's called a ray from the centre of enlargement through a point on the object and its corresponding point on the image, and we can do that for all the points, then we must have got it right. So if you look at what I'm doing here, I'm going to get my ruler, I'm going to draw a line starting at the point of centre of enlargement. I'm going to draw it through a number of the points on the object and on the image, and you'll see that they line up. So I've done it on 4 points here, and all of them are in line.